Okay, now we're going to use these compound and double angle identities to prove certain things here. Now, they give you that the sine of 3x equals 3 sine x minus 4. We're supposed to prove that that's true. Well, there's a trick to this, Instead of the sine of 3x, we write it as 2x plus x. And that gives us sine 2x cos x plus cos 2x sine x. Just look at the identity on your sheet there. Or if you know the sine of the sum of two angles is sine cos cosine, you just write it out. There we go. Now we're trying to get to here. So there's only sine here. Well, there's not too much we can do with sine 2x. We're locked into 2 sine x cos x. But the other one, there's nothing but sine here. So make it 1 minus 2 sine squared x. You got 3 to choose one, but choose that one. And now, cos x times cos x is cos squared x. I want it all to be sine x, so I make it 1 minus sine squared. That equals cos times cos squared. Then we get a sine x minus 2 sine cubed x. Oh, that's looking promising, see? And now just look at it. 2 times minus, that's minus 2. There's another minus 2. That's minus 4 sine cubed. And then we've got a sine x here, 2 sine x there. Hey, it equals the right-hand side. We should have really started with the left-hand side equals, and then say this equals the right-hand side. You should do it that way. Now, let's try this one. I think it's the same trick. Instead of 3x, you make it 2x plus x. And then there's only one thing you can do is use the formula. It's cos 2x cos x minus sine 2x x sine x. Now, if we look at this, we'd like this cos x kind of just to sit here, I think, because we've got a cos x out front. So we probably don't want to multiply this out, but it looks like there's just sine squareds here. So let's go for 1 minus 2 sine squared x. Now, you might be able to do it some other way, but this looks like the best choice. Now, the sine of 2x, we're locked in. We have to go sine 2 sine x cos x. Well, sine times sine gives me sine squared. Ooh, that's looking promising. We've got a 1 minus 2 sine squared. But look at this. We've got cos x is a common denominator. We multiply it by this stuff and by 2 sine squared. And look what we get. Minus 2 sine squared minus 2 sine squared. That's minus 4 sine squared. And there's your answer. That equals the right-hand side. The left-hand side we started with, it equals the right-hand side now. Let's try this one. Cos 4x. Well, hey, I know what that is. That's the cos of 2 times 2x. And that means it's the cos squared of 2x, 2 minus 1. You see, it's all in cos. I had 3 to choose from, but I chose the one that has cos squared in it. And now, but cos squared 2x is 2 cos squared x minus 1. I just want to get to cos x. And we're supposed to square it, multiply it by itself. So you do FOIL on that. So there's your cos 2x. Cos 2x is 2 cos squared x minus 1. Hey, that's the identity. And you square it, you'll get 4 cos to the 4th power minus 4 cos squared, the outside and inside products. And then minus 1 times minus 1 is plus 1. Hey, that's good. When we go 2 times 4, we're going to get 8 cos to the 4th. We're going to get 8 times minus 4, minus 8 cos squared. Hey, it all works out. Now the left-hand side equals the right-hand side. Let's try this one. Okay, I know that the cos of 4x is equal to 1 minus 2 sine squared x. I know that's true. That's the identity. The cos of 2 times 2x is 1 minus sine squared 2x, the double angle identity. That's a little hard for people's eyes sometimes, but that 2 times this angle equals 1 minus 2 times the sine squared of that angle there, of 2x, 2 times 2x there. Well, now, then the left-hand side must equal this, 1 minus 2 sine squared 2x, because cos 4x equals that. Okay, well, 1 minus 1 is 0. And then we minus, we get 2 sine squared 2x. That equals the right-hand side. Okay, let's try this one. Now, this one, it's the same kind of trick, it's the 2 times the sine of 2x times the cos of 2x. There was nothing I could do but write 2 sine x cos x, but I'm looking at a lot of sine here, so I chose the one that was 1 minus 2 sine squared x. And then I just took this cos x and put it on the outside here, and then just multiplied it out, and it gave me the right-hand side. Last question in question 5 here. Okay, the sine of 4x. I figure you're locked into writing sine 2x, cos 2x, and double that. Okay, now the sine 2x, you write sine 2x, cos x, and then you write cos squared minus sine squared. The reason you write that is because if you multiply this out, you're going to get right back to the right-hand side. So it equals the right-hand side. You could write it down again, but that's the whole thing done.